Hello students, today we're going to be talking about solving inequalities. This is building off of our understanding of inequalities from yesterday. So the notes page that you picked up right when you walked in is going to be page 117 in your table of contents. Go ahead and get that copy down for me, and then we'll get started on today's notes. Looking at your notes page for today on solving inequalities, if you look at the very top, we have a vocabulary box to start off with. This box gives us our step-by-step process on solving one-step inequalities. So our first bullet point says, inequalities can be solved by following the same steps as equations. So we're going to be doing the same thing that we did when solving algebraic equations. Number one, the variable must be alone. So in that first blank there, I want you to write alone, or the variable, variable must be alone, or it must be isolated on one side of your inequality. So just like our equations, we're going to want that variable to be on one side of the inequality. We're going to isolate the variable by using the inverse or opposite operations. And then for step number 3, whatever we do to one side, we must also do to the other side. So it's really the exact same steps when solving algebraic equations. However, you have your inequality symbol instead of an equal sign. One caveat or one thing that is different is when you multiply or divide by a negative number, the inequality sign is actually flipped, which we will practice on this notes page and together at the teacher table. So looking at our first problem here, it says solve each inequality, check your answer, and then graph the solution. So for number 1, we have n plus 5 is less than or equal to 16. So when solving this problem, I'm going to solve it just like an equation. So the goal is to get n by itself, and I do that by getting rid of this plus 5 that's with it. Okay, so I'm going to go ahead and subtract 5 because that is the opposite operation. So I'm going to take away 5 over here, making this 0. Now n is by itself. N is less than or equal to, and now if I subtract 5 on this side, on one side of my inequality, I have to do the same thing on the other. So 16 minus 5 is 11. Okay, now my solution should be n is less than or equal to 11. If I check that, if I plug in my value for n, okay, n has to be less than or equal to 11. That means that I could pick any number that's less than or equal to 11 to represent n. In this case, I could put 10 in there. 10 plus 5 is 15, and 15 is less than or equal to 16. Okay, I could even put 11 in there. 11 plus 5 is 15, and 15 is less than or equal to 16. You're just substituting any number that is less than or equal to 11 in place of n to check to see if it's right. So now I'm going to practice what I did yesterday. I'm going to go ahead and graph my value of n. Okay, so I know I could put 10, 11, 12. N is less than or equal to 11, so that means I would put a closed dot on my 11, and I'm going to go less than with my arrow. I'm going to go to the left. Any value that's less than or equal to 11 can be my value of n for this problem. Okay, I'm going to go ahead and solve number 2. Number 2 is a subtraction problem. C minus 9 is greater than 14. Okay, I'm going to go a little bit faster with this one. I want to get C by itself, so I'm going to add 9, making that 0. Now C is all alone. C. I'm going to keep my sign. It's going to stay the same. I added 9 on one side of my inequality, so I have to add 9 over here. 14 plus 9 is going to be 23. So therefore, my C value has to be greater than 23 in order for this inequality to be true. So if I check that, I can pick any number that's bigger than 23. So if I chose 24, 24 minus 9 has to be greater than 14. Let's check that math. 24 minus 9 is 15. And is 15 bigger than 14? Yes. So I know I did that right. Okay. Now I'm going to go ahead and graph that. I had 22, 23, 24. Because my inequality says C has to be bigger than 23, I'm going to have an open dot on 23. And I'm going to go to the right with my arrow because my number for C has to be anything bigger than 23. It can't be 23, but it can be any number that's bigger than 23. Okay, I can try plugging in 23 into the equation. If I did 23 minus 9 is greater than 14. 23 minus 9 I know is 14. And is 14 bigger than 14? No, it's not. So therefore I know for sure I cannot have a value of 23 for C, but I can have any number that's bigger. Okay, now we're going to get into multiplication and division, which is the exact same thing that we've been doing with equations. It's just now we're working with inequalities. So again, I want to get my G all by itself. So that means that I'm going to go ahead and divide my 12 from both sides because right now there's multiplication going on between 12 and G. So if I want to undo that multiplication, I have to divide. That cancels out, and now G is by itself. G is less than, you keep your sign, it's got to stay the same. And if I divided by 12 on one side, then I have to divide by 12 on the other. So 48 divided by 12 I know is 4, but that's a negative 48 divided by a positive. Negative divided by a positive leaves me with a negative. So that means my answer has to be a negative 4. So G is less than negative 4. Now I'm going to check that work. Okay, G has to be a number that's less than negative 4. So it could be negative 5. It could be negative 6. It could be any number that's less than negative 4. Let's go ahead and plug in a negative 5. 12 times negative 5 is less than negative 48. I know 12 times negative 5 would be negative 60, which is in fact less than negative 48. So I know I did it right. I got negative 6, negative 5, negative 4. I'm going to have an open dot on negative 4 because my value for G has to be less than negative 4. It cannot be equal to that. And my arrow is going to go less than to the left for that solution as well. All right, moving right along to this next one here. Okay, for number 4, I am going to again try and get my variable by itself. However, my variable needs to be on the left side. So I'm going to rewrite this problem as negative 7G. I know that my alligator mouth is eating the 49, so I'm going to keep it eating the 49 when I rewrite it. Okay, now I'm going to solve. I'm going to solve for G by undoing my negative 7. I'm going to divide by negative 7. Because G was being multiplied with negative 7. To undo that, I got to divide. Now, this is an added step. If you divide by a negative number, that cancels, right? And your G is by itself. But instead of your sign staying the same, it has to flip. So this would flip to a greater than or equal to symbol. Okay, now I'm again going to divide by negative 7 because that's what I did on the other side of my inequality. 49 divided by 7 is 7, but that's a positive divided by a negative. My signs are different, so my answer is negative. Okay, the reason that you have to flip your sign is this. We're going to check it, okay? If you don't flip your sign, if we left it the same way, right? Say if it was G is less than or equal to negative 7 as my answer. If I plugged in a value that was less than negative 7, say I plugged in negative 8, okay? So if I kept my original equation, negative 7 times negative 8 is less than or equal to 49, okay? Negative 7 times a negative 8 is a positive 56. And 56 is not less than or equal to 49. So if we didn't flip our sign, then our answer wouldn't work out, right? So because I divided by a negative number, I had to flip my sign. So if I go back and I put in my actual answer, a number that is less than negative 7, then I am going to pick, say, negative 6, right? Negative 7 times negative 6 is less than or equal to 49. If I solve that with a value that is greater than or equal to negative 7, which is my negative 6, then negative 7 times negative 6 is a positive 42, which is in fact less than or equal to 49. So I would get the right answer. So that's why you have to flip your sign when you divide by a negative number. Otherwise, it doesn't work. So when I graph my value here for G, I got a negative 8, negative 7, negative 6. I'm going to put a closed dot on my negative 7 because negative 7 would work as a solution if I did put negative 7 in there. Negative 7 times negative 7 is a positive 49, which is in fact less than or equal to 49. It's equal to it, so that would work. And now my arrow is going to go greater than, so it can be any number to the right of my negative 7 to go into that problem. All right, what I want you to do is try and solve 5 and 6 all by yourself, and then we will talk about them together at the teacher table. All right, guys, have a good rest of your day.